Packard, where he's a VLSI design and verification engineer. His topic today is big data and verification, making your engineers smarter. Alan received his Bachelor of Science in Electrical Engineering from Brigham Young University and his Master's in Electrical Engineering from Colorado State University. He's worked in design and verification for 18 years at Hewlett-Packard Enterprise, where he is part of the engineering team that's developing technologies driving a new class of memory-driven exactable supercomputers. He's based in Fort Collins in Colorado. So over to you, Alan.
All right, great. Thank you. I appreciate that introduction. Good afternoon, DVClub Europe. It's morning over here, but I assume it's afternoon over there. I'm excited to talk with you today about how we have used big data in our organization to make our engineers smarter. So thank you for that introduction. But first, I invite you to consider 3 questions. First, what is big data? You know, big data is commonly a used term across the industry. It's often defined by the volume, the velocity, and the variety of the data being collected. However, do we really understand how to get value from this data in verification? You know, in verification roles, we usually want, information, not just the data. You know, information is meaningful results that you can take action on. For verification, I think big data is more about its impact than its size. And you don't need complicated analysis tools to extract and analyze this data. You can start with graphical presentations and use human intelligence to analyze it. Well, how can you utilize this data in verification? Well, are you collecting the verification data you need to answer the questions you have? You need to present that in a way that guides you to the answers, and you need tools that enable you to ask questions about that data that leads you down a path of understanding of what's really going on. And of course, how do you make it meaningful? How do you do something meaningful with it? What verification questions are you trying to answer? Let the data guide you to those answers. I think that one of our roles as verification engineers is to make sure that the people that need the data have it to make decisions they need to make. We're looking for anomalies, we're looking for bugs, for problems, for ways to fix things, or how to run things more efficiently and effectively. We need to get our products to market sooner so we can meet our customer needs faster than we're doing today. And we believe that making our verification engineers smarter by collecting and analyzing big data in our day-to-day jobs will help us do that. So I believe there's more we can do with big data and verification. I'd like to talk with you a little more about that today. But first, I'd like to walk you through some of the different types of big data that we are storing in our lab at Hewlett-Packard Enterprise, and the questions we're asking about that data to help make our verification engineers smarter and more efficient. So we store information in our about our compute farm, like license, disk, and system usage per site, per lab, every 6 minutes. And we can answer questions like this with that data. Only half of the number of tests that normally run this weekend ran. What happened? Why is my job pending time so high today? Or how do I ensure that my most expensive resources, engineers, are enabled and not blocked? With our performance data, we store information like traffic mixes, bandwidth, latency, utilization, various sweat parameters per test, per topology, and we can answer questions like this. Am I hitting the DUT performance metrics we need to hit? Well, when did we stop hitting those metrics? And what set of sweat parameters across multiple tests gave me the best DUT performance? With our test results data, we store information like test metadata, definitions, revisions, pass-fail results, duration, memory, and CPU usage. And we can answer questions like this with that data. Why are my tests running slower and taking longer than expected? Is my test simulation performance optimal? What can I do to make it better? I want to upgrade my compute farm. What configurations will give me the best ROI? My simulation performance dropped significantly over the weekend. What caused it? My test distribution doesn't look quite right. Am I getting the right distribution that I'm expecting, that I need, that I want? Are there any tests being starved, not being run as often as they should be? How do we fix that? And finally, with our coverage data, we store information like, per event name, sim time, values, and per test metadata. And we can answer questions like this with that data. Beyond what was just hit, what was hit in a window of time? How many tests in the past number of months have hit a given metric? And which tests were those? Which tests are really good at hitting a given metric? And how has that changed over time? So why does this really matter? Why are we doing this? Well, we need to get those products out to market sooner. And verification plays a huge role in this. And so to accomplish this, we're using this data that I just showed you to drive more accurate bug rate projections, simulation and DUT performance, forecast of licenses, compute resources, engineering resources, schedules, and to equip our verification engineers with all the critical data they need to be able to enable them to make smarter decisions for our current and future ASIC projects. So we found that by identifying new data sources, collecting them continuously, and inventing ways to analyze them has helped us reach those goals. But it really comes down to the questions you ask. And so I'm going to briefly show you some examples of how we are presenting and analyzing the data we collect. The full case studies are discussed in greater detail in my DVCon 2019 paper and the presentation that I gave there, but I'll touch on a few of them here. Our compute farm data helps us solve the following problems. We're purchasing a large number of licenses, and they're not cheap. Having big data and tracking license utilization over time has helped us understand that actual demand versus expected demand that teams need. And it's helped us make more accurate forecasts of exactly what licenses to purchase and when to meet that demand. With expected versus actual utilization, we know we aren't using our licenses. We know when we're not using our licenses effectively or efficiently. And so we can spread those licenses out across our verification teams to get better utilization. So when we run out of licenses, you typically spend more money to get more licenses because you don't have the data to tell you what's really going on. And so we can avoid that if we have the data. And we can also see from big data which organizations and sites have been using the licenses, and we can pinpoint where the problems are coming from and ask them to adjust their utilization appropriately. In our second case study, we used our performance data to help us debug an interesting performance anomaly in one of our data mover blocks in our chip. We used our performance data and automated checking and plotting tools to understand and root cause and fix this issue. So this is a plot here that shows input versus output bandwidth of a particular data mover operation. And with each data point here on the plot is coming from a specific performance test that's run over time. So the ratio of input to output bandwidth is related to the size of the transfer request. So we would have expected to see a tight clustering of points around the expected bandwidth numbers, but instead this plot showed that something changed on this that caused those numbers to fall off between the 17th and 22nd of April. So we run and record and analyze and plot data from our performance tests every night, and if the numbers fall out of expected ranges, a failure is reported for the verification engineer to look into. So we leverage that power of big data to automatically tell us when something goes wrong. We don't have to look and analyze our performance test results each day by hand. We have scripts and processes running that show us, and so we were able to pinpoint that bug very, very quickly and resolve that issue. Well, our test results data, it helps us ask and answer the following questions. Are we properly balanced between each test bench? Are there any that are being starved that need more cycles? How effective are we at finding bugs and issues in the DUT? And what do our open and close rates look like? And how does that bug rate compare, with our verification cycles over time? Are we running the right test to find those bugs? You know, am I getting the right distribution of tests? Are any being starved that need more time? You know, we also found that our simulation performance was degrading over time. You know, besides engineers, licenses are the most expensive resource we're consuming. So it'd be good to run the sims as efficiently as possible. Or, you know, we want to upgrade our compute farm. Well, you know, what configuration do I need? You know, we found that by analyzing the max and min and average CPU memory utilization times, we can make that determination about our farm and get the best ROI from it. And my final use case here is our big coverage data has helped us close coverage faster. We've applied big data methods to functional coverage. And we found that there's several advantages over the system Verilog cover groups that we frequently rely on. So our work here is incomplete, it's ongoing, but I thought I'd just give you a little taste of it. Typical cover groups just record whether a specific condition within a block has occurred, but with a sufficiently large database, you know, it becomes practical to record all value changes and events for interesting signals within a design, such as state registers, buses, enables, and stalls signals. And if you record enough context with each value change, then you can ask more complex coverage questions about that data. And so by recording those events throughout the simulation, defining functions that operate on that data, using filters to apply to that data, visualizing that data, and providing a REST API to that data, we've been able to ask very rich questions about coverage that go beyond what just the EDA tools alone can provide. So all of the things that I shared with you today were made possible by the tools in our Big Data Toolkit. You know, we use our Big Data Toolkit to collect, to analyze, and present the data that guides our decisions. You know, most of these tools are open source and freely available, which lowers the barrier of entry to use them. You know, you don't need a cloud or expensive licenses to create and analyze your own big data. And so I've tried to kind of show you that here through these tables. And again, these are all the different tools we're using. And I know there's many more out there, but again, you can get started today. I am going to give a shout out to Grafana. If you haven't played with Grafana, it has dramatically simplified our ability to query any database data source you want and plot it in a very rich and easy manner. So we've given up on all of our custom plotting tools. We use Grafana, and so I just want to shout out to Grafana. That's a great open source tool for that. Well, the future of big data in verification is bright. We think there's a huge opportunity here for us and EDA vendors, and we want to do more with intelligent test grading to get more value from our cycles based on our own criteria. We want to store more dynamic, unstructured test data as needed on the fly from the test definitions or during test bench execution. If a verification engineer decides they want to know if something happened, they can record that instantly that night and see which tests are hitting that interesting thing that they're looking for. Well, we want to do more with machine learning and AI algorithms to help us spot patterns in the data and answer questions about it better. We want to query and merge data across multiple data domains, multiple databases or data sources to combine queries and answer even more complex questions. Well, I hope you've seen through this brief presentation today that answering questions with big data can help our verification engineers be smarter and more efficient, and that big data is no longer big and scary. You know, it really is in reach for every verification engineer. You just have to make a decision to get started. And that's the approach we took for those case studies I showed you today. And as you ask questions about the data you collect, you will be led down a path to deeper understanding about what's really going on. And as you let the data guide you to the answers you seek, people that need this data to make decisions will be better enabled to do so. You know, making our verification engineers smarter by collecting and analyzing big data in our day-to-day jobs will will help get your products to market sooner and meet your customer needs faster. We've certainly found that in our lab. So I leave you with this call to action today. Now is the time to ask the questions, collect the data, and analyze the metrics to help your verification engineers make smarter decisions with big data and help your products get to market sooner and meet customer needs faster. All right, thank you. Any questions?
Thanks, Adam. We've got one question from Bristol. I'll hand over.
Hi, I'm just wondering how you extract the coverage information and get it into the database.
Yeah, that's a great question. So we use some DPI calls. And so there's two different approaches. One is some DPI calls that we make directly from the system Verilog or community code out to the database. The other thing we've done is just extra logging of metadata that we then post-process and suck into the database once the test is finished. So that was our first approach, was system Verilog, spec community, Verilog. It's easy to spit messages out. And if we make those messages concise, we can parse those and insert them into the database. But again, we found that making those DPI or VPI calls directly also is giving us greater speed in that regard.
A follow-on question for that. What format do you store that coverage data in?
Yeah, great question. So we usually will dump that. We'll log it to a separate file. It's usually a tight CSV text format that we then suck into the database. And so generating that much data per test certainly generates some large files on disk. And so you've got to have some good disk resources in your farm if you want to collect kind of coverage data. But we found that to be very feasible. And one question I had at DVCon was, well, what's the impact of simulation performance? And we found that when we turn on or instrument that coverage collection, it's about a 10% hit to the performance of the sim.
In the past, we've tried to do this SQL, but SQL doesn't really scale, unfortunately.
No, SQL doesn't scale well. We've moved to big data databases, unstructured databases. We've been using Vertica. We've dabbled in Hadoop and Spark, and also MongoDB as well. And we found that unstructured data lends itself better to these large data sets and doesn't require you to define relational database schemas up front, that are a little more rigid. As your data changes over time, unstructured gives you a little more freedom in how you collect, store, and analyze that data. But we certainly have some relational databases, don't get me wrong. Most of those databases I showed you were structured. We've been moving more towards the unstructured to give us more flexibility. But structured is a great way to start.
Yeah. Okay. There's no more questions. Thank you very much, Alan.
Thank you, and I encourage you to look at that DVCon for the full presentation and the slides. I've sent those over to Sarah, and they should have the full slide set posted, but you can access the paperwork slides from DVCon 2019 US. Thanks for your time today. It was great being with you all.
Thank you. Thanks, Alan.